What do you have the PASCO AC/DC electronics laboratory circuit board out for, JJ?
We're going to do an experiment with a circuit that has a resistor, actually two resistors and a capacitor in it, or an RC circuit.
Well, I can sort of see a circuit here, but I'm not sure I'm understanding the pathways here. Can you point out the details?
Yeah, so I'm going to put this up for a second. This is a diagram that we're used to seeing, and this is the diagram of the circuit that we're going to use in this experiment. And so there's a 3-volt battery source here, a switch, a couple of resistors. One is in series with the capacitor and one is parallel with the capacitor. And so let me explain how that sort of shakes out on our circuit board here. We've got two batteries connected in series. There's a little wire here that connects the positive and the negative of the two batteries right here. So we get 3 volts as a result. And then we've got a little push button switch here. So the top of this battery is connected to the push button switch. And then this is connected to this resistor right here, which is our 33 ohm resistor.
Okay.
And then we've got wires that connect across these two spring clips to a capacitor over here, which is 470 microfarads. And now you may have noticed the little arrows on that.
Directional. Not all capacitors are, but this one is.
Right. So we make sure that's set in the right direction. And then there's a resistor connected between these two spring clips right here. And then there's a couple of wires that are connected together here. So the bottom of this capacitor and the bottom of this resistor are connected together.
They're in parallel.
Yep, in parallel. And then that is in turn connected to the back of this battery here. So we have a nice closed circuit.
Okay, it does match that circuit diagram really well.
I'll just throw that up there again for a second, make sure we all sort of see what's happening.
Now we have the wireless current sensor and the wireless voltage sensor. So I assume we want to measure that across each of the components in the circuit.
That's exactly right. In part 1 in the lab, we start with the capacitor. So we're gonna measure the voltage across the capacitor while also measuring the current
through it.
So here, why don't I give you that voltage sensor and you connect it to the capacitor across it in parallel. And then I'm going to take this current sensor.
Because the current doesn't really flow through the voltage sensor. It has a really high resistance to prevent that.
Yeah, so it's going to measure the voltage.
It just goes across.
Exactly. And then to measure the current through the capacitor, I'm going to take this white wire right here, and I'm going to take it out, and I'm going to replace it with this current sensor in series. So the current's going to have to flow through the capacitor, through the current sensor before it makes its way.
So the charge is going to flow through the current sensor instead of that wire. It just takes the place of the wire.
That's right. So I'm just going to.
So they work very differently, and we have to be careful as we hook them up. And then I also see you're putting the positive.
Yep.
The current will flow from positive to negative.
That's right.
The charges will flow from positive to negative.
That's right. So yeah, we're gonna measure current as it flows through this ammeter and then back. Oops, I'm sorry. This goes right there, because that's where the wire used to be. The wire used to be connected from here to here.
So I have a voltage graph and a current graph, and we're measuring at 1 kilohertz. So if this happens fast, we should be able to see any changes. And there's a switch would close the circuit. So whenever you're ready, I'll hit record.
Okay.
And so we have our data, and you can see the voltage went real rapidly up to some steady value across the capacitor, and the current just quickly went up to some maximum value, then dropped to 0. And then when you release that switch, so this kind of switch makes a connection when you press it, and then when you let go, it disconnects. And so the voltage went to 0, and then the current flowed again very quickly and then was gone.
Right.
We can take a closer look at it. This is something you'll want to do when you're analyzing this data. We're going to give you all this data. So I have put the selection box around that, and I want to blow it up. So I'm going to hit auto scale. And so now we can see that there's a curve here. It's a very characteristic curve of charging a capacitor, and then same with the current. And so once the capacitor reaches its full voltage, current stops flowing. So that's something you may not have known.
And that's what we call steady state. So when the current's not flowing, those are where you would make your steady state measurements from this data that's in the graph, which we'll give to you to make the measurements on your own.
And then if we were to look here at the discharge, and again, you will be doing this. And so I select that, and I can select it so it's all purple there. And so we can see the discharge, another sort of the inverse of the charging, similar sort of mathematical function would describe that. And then the current also drops to 0. So what they're going to need to do is also measure the voltage across the capacitor in steady state, and the current across the capacitor, well, that's kind of obvious, or the charge flowing through the capacitor, its current at steady state, and record that in the data table in the lab write-up.
That's right. Okay, so that's the data for part 1 of the experiment. Part 2 has us, instead of measuring the voltage and current across and through the capacitor, we're going to move this to our 33 ohm resistor right here. So we'll measure the voltage across the resistor and then through the resistor. And so just like you had on the capacitor, we'll connect those leads in parallel across that resistor. Oops, out that just yet. And now there's a blue wire right here that connects this end of the resistor to these 2 components. We're just going to pull that blue
and replace it.
Yep, and that's just a little snug, so I'm going to take that off for a split second. And then replace that with our current sensor. So we're going to go from there to there. Whoops. Okay. And then we need to put that
jumper wire. Yeah,
we got to put this wire back.
So run number 2 will be the voltage across the 33 ohm resistor, and then the charge flowing through it, or the current of the 33 ohm resistor, which is in series. So this is part 2 in the lab write-up. So whenever you're ready.
All right, go ahead.
And so we can see something similar, but not exactly the same. The voltage went up and then dropped down to some steady state value and then dropped to 0. And so the current, and then the current also went up to some value, but then didn't drop down to 0, and then eventually did after we closed the switch. And so current is flowing through that resistor even when the capacitor is fully charged. So you'll need to be able to explain that as part of the lab.
All right.
You also will measure the steady state voltage and the steady state current. So you need to understand this circuit. You need to understand about charging and discharging, but not mathematically. You do need to be able to understand the current and voltage values once it's fully charged capacitor and discharged.
Exactly. Okay, so for the last part, part 3, we're now going to move our measurement tools from this 33 ohm resistor over here to this 100 ohm, right?
100. Okay. It's a little resistor, but a bigger resistance.
Physically smaller.
So it makes it harder for the current to get through. And so we have choices of where to get the current through it, but probably be easiest is to get it going in.
We got the voltage sensor hooked up to measure the voltage across the resistor, but now we want to be able to measure the current through it. So the first thing I'm going to do is I'm going to replace this wire that we took out for part 2, this little blue wire here. And now I'm going to take out this red wire right here and replace that section of wire with our current sensor in series.
So the only way the charge can flow is through the ammeter or current sensor.
Right. So let me connect that here. And I might also add these spring clips have two little springs, and those are electrically connected. So you'll see here that this black alligator clip and this red alligator clip are clipped to two different split springs.
But it's the same.
But they're electrically connected. So I'm going to take this and put it here. So now we're measuring voltage across this resistor and then also the current through it before it meets back up at this junction here. So right here is where we're measuring current.
So let's see what that looks like. You ready?
Yep.
And so difference.
Yeah.
And so you'll have to be able to explain that as well as also is reading the voltage here and the current here and trying to understand that. So you will have this data file and all the tools in Capstone. You'll have the student handouts and this video to help you complete this lab on RC circuits.